Hello Earth, welcome to episode 34 of season 4 of Making Cell, a series of videos where I record myself designing and implementing a programming substrate called Cell. If you're just tuning in for the first time, I recommend you go check out github.com/autocornell/cell. I'm pasting now the link in the description. So, yeah, let's continue where we left off. I am, I want to say in a crisis, but been severely challenged by seeing things that are being done just with swarms of AI agents being basically programming systems that their creators don't really understand except in their top level descriptions, and they're still managing to get useful stuff out of it. So that basically goes let's say against the core of what I'm building towards, which is the creation of small systems that you understand and are very useful. It's being replaced with big systems where you only have a very top level understanding, and the AI builds everything and you barely look at the code or not at all. And if that works, I don't know, all bets are off. They really are. Then really what we call high level programming languages are just assemblers, something that almost nobody looks at anymore. And what replaces that is natural language descriptions that don't even have to be that good. Although I guess if they're better, you can probably get better results. I guess. I guess I didn't have to learn programming. So it's all in flux, right? And I realized I've been doing things a lot by myself, having that feeling that, okay, I'm building Cell myself. Sure, I have help from the AI, I ask things from the AI, but I'm in the driver's seat. I'm typing, and I wonder if that's obsolete. And I really don't know. I really don't know. So I'm in a very interesting spot because I don't know, I cannot ignore what I'm saying, and I don't want to just give in to it either, because I feel that I'm leaving valuable stuff behind. So I have to find not a balance, but I need to find a synthesis of what I need to take with me forward, that I was already doing, and what I need to embrace in the new. That is not all of the new, it's just a part of the new. At least I know that the future is coming through Cloud Code and things on top of it. So I was just basically going through the README with Cloud here. So let's just think of the problem that I'm having right now, which is I'm trying to figure out how to build a chain of dependencies. Okay, so let's see if we can get the help here of Cloud. So we have this thing, this chain here. I mean, it's still not doing it the agentic way, basically telling 5 sessions of Cloud Code, okay, see those to-dos for Cell, okay, do it, I'll check with you in the morning, and then I see how far they got. Maybe they implemented conditionals, maybe they implemented whatever thing I wouldn't have gotten around to implementing in 1 or 2 months. And maybe I should do it that way. So I'm not sure if I'm just too clingy to trying to understand the low level details of, for example, how the dependency chain is recalculated. So if I just go, let's think about what should be done. So I have an execution of FISBUS, or SysBus actually. The S is for single. So let's just expand that. What am I doing? There. So here, the result would be 4. And here the result would be sys bus. Here I guess the diff would be something like it's interesting to have the absolute there. Maybe that's, yeah, but it has to be, it's a good decision. Otherwise, how do you know? Well, let's see. We need hours of flight here. Huh? A lot of what this revolution is doing is just basically about quantity. Interesting enough, quantity and intensity. This was basically 1. No, what am I doing? No, it's just output. Yeah. There's no expansion because it's native. If conditional mode, it will be n is 15. So you already know that this is the mod is 0. Yeah, this works. He will be remove this. Yes, I like this. So you see how the variable is changing as a result. Take that, functional programming. So I got lost. Maybe I should not implement. So I should make agents hand roll it. That's gonna be fast. So the else is that, of course, I need to put the add, which is add push output bus. Sorry, this was 15, sir. What the hell are you doing? Sure. I see nothing like this. 27 years. This is the same, except that here I missed the 3. Sure. Bam, bam, bam. Ever appear. I ain't seen nothing like this. Oh my, 127 years. This is, why does it say bus here? Because I'm just copying the wrong thing, silly. Sure. Nice, 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 nice. I ain't seen nothing like this. I wonder how clear it's going to be look in the editor. I think this is better than what I'm doing in JavaScript for sure. I can see the results. Already not having a... I'm gonna write it down. Where is it? Perhaps how I'll feel about cell, in that I no longer how to write console log. This is a great article. Yeah, what a great article. Okay, so that wasn't an easy, hard expansion to write. So why the hell is it so hard? Because I didn't implement the put, right? Yeah, or push. What's the chain? This bus doesn't depend on anything. Except on itself. If it changes, its result is wiped. Let me say it again. Depends on this bus. That's it. Can it be that simple? That sequences depend on their definition and message? Perhaps. That removes the dependency of the result on that of the expansion. If you're redefining stuff all the time and you have huge sequences and you want to preserve intermediate results, it could make sense to cache some of this, but maybe we're not there, but we are not there yet, and we might never be. So you have a call prefix. The call prefix depends on what comes after it. Any at after it you see where it takes you, and that's what you depend on. There could be instances where the rag is pulled from you, from under you, perhaps, if something gets in the way, variable capture, or something goes away one or two steps. But that would also affect the call prefix itself, right? It would. Otherwise, you could not go find X outside of that prefix. So we should be okay. It's like this, exactly like this, for reactive views. So in this case, I'd say it's very simple. That's all. Sorry. That's it. Sure. Okay. So now what? So if we have this one, let's move Jamie to the top here. So where is message here? Or just return what you're sending, of course. That's just very easy, right? Call depends on def. Okay, and now what have I been glazing over here? What did I miss? I missed that. Sysbus. Not Sysbus 15, Sysbus. Depends on put, if, and mod. And push, right? So at definition time we do a dependency chain the name of the sequence for the path, call prefix of the sequence, so that we can affect any reference to the sequence itself. This has a few disadvantages, but I'm okay with it. The disadvantage is to do this eagerly rather than on expansion, but because the expansion depends on things that can change, it's just too dynamic without you having to go and check it anyway. I think it's cleaner, and also because then you don't have this was 15 well, or put, it's indirect. And also I forgot what I was going to say. No, also if there's a reference to the argument, to the message, that should not be a dependency, because it's already, because if it's a constant, it doesn't change things on recomputation, and if it's a reference is anything that is not a constant, then, which by the way is a better name than literal. then it's a dependency of the call prefix of the expansion. Rather than saying the sequence execution, we can say sequence call. No, because they are both calls. You have the call to define and the call to expand. Let's use the term expand. I could ask Claude to write an intro on on how you would program with this. What would make this more readable? Yeah, so what's... I'm a bit stuck, honestly. On the someone, what would it be? Dun, 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 dun. That's one, right? Dun, 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 dun. Sure. What am I doing? Undo is what? Is simply this equal to 11, which is add 10 int It would be interesting to have this. I'm gonna be hanged for this. It would be interesting to have something like this. 11 at int. So you could really know where it came from. Ah. Although here you have no place to hang it, right? Because you could not say that it comes from +1. Unless it is something ugly like colon +1, colon +1. What if references, plain references, also have expansions that tell us where they come from, except perhaps for the native ones, absolute paths that you can look at. This is too experimental even for myself. Yeah, we have a sequence. Like here you would have something like this. I wonder if it's just too much noise. Okay, so what's the score? I build the prefixes. I think it's pretty clear, right? What I need to do. What is to be done? Pairs for each call prefix. Silly linear search because we cannot use hashes, at least not directly. It's not pairs, it's chains. When putting, use Godov's logic for every path you're putting to discover what's affected. Wipe the results. Then run things anew. Change respond to skip computing things that are already computed. Nice. Okay, let's stop with a cliffhanger here. Okay, time to fly. All right, we have 10 minutes here. How would I do it myself in the meantime? Let's play John Henry. You find a call prefix. Is there stuff? If there's a chain for it? Actually, you don't even have to look at the chain. How would I do it? If there's a chain, there's a result, and vice versa. Right? That assumes things come at the same time. I needed to check that actually. But if the result comes before the chain, I just look at the result because it's cheaper than finding the chain. Yeah, that wasn't an easy one. I have an error for this one, right? One call per, yes. This test suit is the best thing I've done in Cell, I think. When I think of the implementation, I think of this more than this. Yeah, this is definitely not something to be expected anything soon, but I still don't have the ideas clear in my head. So I find the call prefix, I look at what's behind it. If it's a definition, I need to go in. I had this clarity the other day about, where was it? Yeah, this one. Yeah. Yeah, the entire problem is to compute results and dependencies for sequences. That's correct. Yeah, that's a good conclusion. Oof. Goodbye, my limit. Should be stored inside the data space. The whole problem we're tackling is about dependencies of sequences. The rest is trivial. Go for it. Okay, let's see. Let's see what happens here. So on a definition of how to go deep, well, here actually would be easy, right? The first change would be okay, again, if there's a result, don't do anything. Otherwise, it's an if. Put if in the chain, also the stuff inside the if in the chain. It's a sequence definition. Put do in the, actually we need to put do in the chain as well, right? Put the destination after walking it. No, sorry, what am I doing? Yeah, no, that's not hey. I already knew it was that, right? Yeah. Put do in the chain, then walk the entire definition without resolving anything. No, wait. You need to solve absolute paths of references. You don't know what they are referring to until you get the context. How will you know if there's a nice thing called mod inside the message? You can't know it. Uh-oh. Uh-oh. How will you know? How would you know? You cannot know it. It's one thing to do unnecessary work, no problem, but another one to not know if it goes out or not. It's so completely dynamic. You don't know what's going to be passed. I guess you have dependencies. You can be conservative and assume that the call prefixes inside the sequence point out of it and find the absolute ones outside, except for the name of the message. Wait, if the message is named, you cannot have other capture there. So never mind my point. You can know if you're referring to the message or not. Well, if on step X you create mod, then you do have to execute it. But you can be conservative and point to outside on all of the call prefixes and redraw just in case. Sure. I need to stop. Interesting. Yeah, that makes sense. Hell, that makes sense. I picked up. I has to use the mute. Oh my! Oh my! This is good. Oh, it's wiping it. Yeah, but that's removing it. Well, I think it's just deleting too much stuff, but it's okay. Wow, man. Wow. Fuck. Ooh la la, look at that. That's input, I guess, right? Yeah. Yeah. It's unnecessary if you're going chain with a mute to invalidate. And then you're just wiping. Yeah, but then when are we wiping the results here? Oh, brilliant. Sure. Oh, nice. It figured it out. Yes, go for it. even if it didn't work, it's interesting because it's validating the ideas. I'm getting a quick implementation and saying, okay, what is working, what is not. This is crazy. This is crazy. That's where yeah. Yes. Interesting. Oof. Look at the yeah, so it's basically copying the stuff for a wipe, sure. We can always merge it later. Interesting, because I put the assertions on what wipe is returning. Going down the stairs while I watch it. The output of cloud code. I like how it's repping instead of reading the whole thing for the thing that fails last time. Tests are super interesting like this. They're super useful, not interesting, I mean. Okay, I'm gonna stop here. Thank you for watching.